Hi, Victor Morganti here from FactEngine. We're going to have a look at semantic modelling for the enterprise with focus on FactEngine Knowledge Language, which is a business language or rule-based controlled natural language for knowledge engineering for corporate or enterprise modelling. And at the same time, we're going to look at a new way of looking at databases, which is coming to be known as either relational knowledge graphs or the graph relational paradigm. We're going to do that inside the Boston Conceptual Modelling software and see how FactEngine Knowledge Language, or FEKL, it forms an integral part of how Boston does knowledge engineering, and where FactEngine's namesake, FactEngine, fits into the picture with FactEngine Knowledge Language as well. So we're sitting in front of the Boston Conceptual Modelling software, and in the left-hand side we've got two models that are open. So the Northwind model, which is a conceptual model of the famous Northwind database by Microsoft, and we'll use that for demonstration purposes. So an enterprise, Northwind, and we've got a data vault extrapolation of that same model. So we have the Northwind corporate model and the data vault extrapolation of that, so two separate models. We'll start just looking at the business vault, so the standard interpretation of the conceptual schema, because it contains all of the semantic modelling that we need for this enterprise. Before we look into the semantic side of things, let's have a look at a traditional view of databases, and then we'll see the new paradigm, so relational knowledge graphs, or the graph relational paradigm, and then we'll look at semantic modelling and how they all tie together inside Boston. So if we look at a entity relationship diagram view of the Northwind database, or which represents in this case the enterprise, we're looking at an enterprise that has employees and customers, and where customers can place orders that are taken by employees, and the orders have order details for products manufactured by a manufacturer, supplied by a supplier, that fall into a category, and where an employee covers a territory that's in a region. Orders are shipped by shippers, and customers have a many-to-many relationship with their customer demographics, so a customer can fit into multiple customer demographics. So far so good. So this is a standard way of looking at a conceptual model, especially over a relational database. Inside Boston, we can look at the same conceptual schema as a property graph schema. So this is a property graph schema as if we were looking at a graph database, and we have the same basic node types or entities in the ERD view of customers, employees, orders, shippers, products, manufacturers, suppliers, demographics, territories and regions. In Boston, we have a extended view or extended way of looking at the model, in that we can morph between the various views of the database or the model, and appreciate that under a new paradigm all databases can be viewed as a relational database or a graph database at the same time. So we look at customer again and go to its property graph schema view. We can see a node type with its properties, and intuitively we get a feel that the relational paradigm and the graph paradigm can sit happily together in the same database. Now that's been known for a while in database spheres, where it becomes more akin to what we're looking at, semantic modelling. The graph paradigm is closer to semantic modelling that business people understand. So an order was taken by an employee. An employee covers a region. They also cover a territory that is in a region. And a customer has a customer demographic. So we've got predicates which puts the relationships into natural business language. And the world's been heading that way for a little while now as well with graph databases. Where Boston and FactEngine take things one step further is that if we say pick on order, we can go to what's known as its object role model view as well, where object role modeling and the FactEngine knowledge language form an integral part of how Boston provides what we call the semantic view over the top of your databases, but at the same time provide a mechanism whereby we can have an ontology, so an enterprise-wide or corporate ontology for, say, our data warehouse when we come to make our data vault for our data warehouse, for example. Now, object role modeling breaks the world up into fact types, where, say, an order was taken by a customer, an order is for a customer, was taken by an employee. An order has a ship region and has a ship postcode, etc. And where these fact types, if we select any one of those, we can view its what's known as a verbalization in object role modeling. So orders customers, that's just the name of the fact type, but if we read it, we say order is for customer and each order is for at most one customer. And it is possible that more than one order is for the same customer. So we have a business language or business rule for our data model captured in natural language or business language that we can use to form our corporate or enterprise ontology, which at the same time can be used for our business vault view over the top of our data vault. Now that's just one verbalization. If we go to the model itself and look at a glossary and say select order again, we get a detailed view of all of the fact types that relate to order in business language. So order is for at most one customer, order was taken by at most one employee, order has at most one freight, order was on at most one order date. Now these could be one. So if it's absolutely mandatory that an order is is only stored once we know its customer, we can add those rules because our object role model comes in two parts: verbalizations in business language and the corresponding object role model. Now if I find the relationship between order and customer, here it is here, and I make that particular role played by the order mandatory. Now when I go back to my verbalizations, so my business language view, we're saying that each order is for one customer. So not at most one, it's not optional. We're saying that it's mandatory that an order is for one customer. And a customer possibly has more or placed possibly more than one order, etc. So where does FactEngine Knowledge Language fit into all this? Before we dive into that, let's have a look at FactEngine itself. So FactEngine is the name for the natural language query component of Boston, and that sits over the top of the Boston meter model. So FactEngine can be purchased as a separate product from Boston as an API, for instance, and it ships with Boston as well. And it takes natural language to the next level again. So if we open FactEngine, we can ask questions about our database, such as what is the total customer value of customers that placed orders in 2017 for products that have a supplier that is based in the USA. So that's just straight natural language. Let's hit go on that. And FactEngine will convert that natural language query to a controlled natural language query called FactEngine Query Language, which reads which customer made an order that was placed on the order date year 2017 and is for a product that is supplied by a supplier that is based in country USA and has which total customer value. And here's our results. So natural language is permeating right throughout Boston, and with FactEngine sitting on top, and where you might start to think, well, I'm looking at a database. Well, really we can be looking at any database, because FactEngine Query Language can be converted to a number of different languages, including SQL, OpenCipher or Cypher, and TypeQL. If we look even closer, and if we knew anything about the Northwind database, we'd know that on the standard Northwind database there is no such column on the customer table called total customer value. And if I click on that particular column, I can see that it has a business rule, and that business rule is customer has total customer value is where customer placed an order that has an order total, and then we want to return these particular attributes and with the order total sum. So the customer ID and the order total sum as total customer value. If we drill down, we can see that there is no order total on the standard database, that this too is a rule on the order table, sorry. So if we click on order total, we can see that it has a natural language business rule which reads order has order total is where order is for a product, and then we want to return the order ID and the unit price times the quantity minus the times 1 minus the discount, and get the sum of that as the order total. So that's not in SQL, it's not in a programming language, other than that we consider that it's in FactEngine Knowledge Language. And so FactEngine Query Language and FactEngine Knowledge Language form pretty much one and the same thing, where this business rule and customer total customer value business rule, if I go back to FactEngine, have been converted to a into subqueries. So this much of the query is for order has order total, and collectively this much of the query is for customer has order total, and then of course we have the entire query which gives us a result for what is the total customer value of customers that placed orders in 2017 for products that have a supplier that is based in the USA. So Boston and FactEngine extrapolate away from the crudeness of the lower level details required to query databases to get our results, and where natural language permeates right throughout the relational knowledge graph paradigm, or the graph relational paradigm. Where even the natural language queries are graph-based queries. So of all the graph query languages, controlled natural language is a very handy graph query language where we join things together using predicates and natural language. So let's have a look at FactEngine Knowledge Language itself. To do that, let's go back to the glossary view inside Boston. So we're looking at the Northwind database. This is our glossary view. We can click on customer and see all of the business rules for customer, and with our derived fact types, so our on-the-fly business rules that will collate data for us. So each customer has one total customer value, is a derived attribute that says customer has total customer value, is where customer placed an order that has an order total, return the customer ID and the sum of the order total, etc. We might look at that through this list as a business analyst or somebody who needs a report or something like that, and notice something crucial that's missing that we need to store in our data warehouse. We might then look over at the entity relationship diagram view and look through all the different attributes or columns for the customer entity and notice the same thing, that for our business every customer needs a username for when they log into an online portal to place their orders. So we need a username against customer. Now we can click on the entity and add a new attribute as if we were working in a traditional tool for doing conceptual modeling of relational databases, or where the world is moving to with graph databases, even though this is probably the most advanced graph database interface that I've seen. We might look at the properties for customer and see that once again username is missing, and click on customer and add a property, and we could put our username as a property against that node type, as if doing traditional conceptual modeling using traditional tools for conceptual modeling. Or we might just say, well, you know what, I'm a business analyst, I'm going to use natural language. So Boston has what's known as a virtual analyst, which lets you use FactEngine Knowledge Language to modify the model. And we know that all of Boston and FactEngine have at its core object role modeling, and verbalizations are an integral part of object role modeling, and FactEngine Knowledge Language is a subset of the grammar that's used for verbalizations. So we might say something like, customer has one username, and that defines username. But we know that we're creating a data warehouse, so let's give it a data type. Let's say that its data type is text fixed length, and we're going to be generous and say that you can have a username up to 200 characters long. So in natural business language, we've defined that a customer has one username. So if there is a customer, they definitely have a username, and they've got 200 characters within which they can write their username. So if I hit go on that, Brianna, the virtual analyst, will ask me, would you like me to create a fact type for customer has username? And I'm going to say yes. So now when I click on customer, within my set of business rules, I will see that each customer has one username. And when I look at my entity relationship diagram, I now have a column on my entity relationship diagram on this entity customer username. So that's there. And if I look at the property graph schema view and look at the properties for customer, we've got username there as well. So between our business glossary, our entity relationship diagram and our property graph schema, we've got each customer has one username, and where natural language has become integral to the whole model. So FactEngine Knowledge Language is not only a conduit into the data model in terms of being able to create the data model using FactEngine Knowledge Language, but because it's a subset of verbalizations in object role modeling, it becomes part of the model itself. Before we have a look at how useful indeed that can be for semantic modeling for our enterprise or corporate knowledge graph, let's have a look at another aspect of object role modeling, and under the paradigm of the FactEngine Knowledge Language and Boston and FactEngine, where if we go back to the entity relationship diagram view and we look at this entity here, employee covers region, that particular entity or table isn't in the Northwind database. So this is a derived entity. So if I click on that, I can see that employee covers region is a derived entity, where employee covers region is where employee covers a territory that is in region. So an employee with the many-to-many relationship between employee and territory. So an employee covers a region or a territory that is in a region. So if they cover the territory that's in a region, then we're saying that by default they cover to some extent that region as well. So this particular entity acts as a type of view. Now that view, or that ability to create views, need not be necessarily over this particular data structure or schema, but over the actual data vault schema, such that we have a business view over the top of our data vault. Now you might not want to do that inside Boston itself, but there is an option that if we're querying the database anyway on an ad hoc basis with FactEngine query language, and let's face it, we're never going to get away from using low-level query languages like SQL and Cypher, etc. Not for really big queries. But for ad hoc business queries, so business intelligence queries, if we were using FactEngine, then we could create a set of views which just sit over the top of our data vault, and where we have a customer's hub and a customer's satellite, which might have our new field in their username, and we have an orders link and an orders hub, etc. So having the ability to create derived fact types and derived entities, we can have the ostensible views without having written any SQL or Cypher itself to be able to affect those views when we're querying in FactEngine. But we might want to actually have the views in the database. So let's have a look at where Boston and FactEngine fit into that. FactEngine calls it the Semantic View, where Boston, so this is Boston sitting here, becomes a semantic view along with FactEngine over the top of either a semantic layer or your database or your data warehouse or your data lake, where we have three different types of view. We have the business language or natural business language glossary view of the corporate model that's stored in our data warehouse, or we have the object role model view, or the entity relationship diagram view, or the property graph schema view. So with Boston available on a desktop, business analysts can be using it with the glossary view to create business rules in natural language. Together as a team using Boston on the cloud, we can develop our enterprise model. And for ad hoc queries in natural language, so business intelligence queries, we can use FactEngine sitting over the top of this semantic view over the top of either a semantic layer or your data warehouse or data lake, depending how you develop your architecture. So why is that important? Well, it all comes down to risk. So there's an extraordinary amount of risk on this side of the equation. So with your semantic layer or your chosen database for your data vault or your databases for your data lake, etc., there's an extraordinary amount of investment that goes into setting those things up and maintaining those, compared with at least the purchase price of Boston and FactEngine. If we factor in the time to develop your corporate model and look at the risk that's involved there, let's go back to Boston for a second, that if you're not seeing the value in having an entity relationship diagram view of your enterprise model, a business glossary of your enterprise model that I can navigate around, so if I say customer has at most one address and then click on address, I can see that address possibly has more than one customer's satellite. I'm inside the data warehouse view. Let's go back to the standard view. So if I look at address, customer has at most one address, employee has at most one address, and address possibly has more than one supplier, etc. So we can see that the address value type is used across there, and we've done that all inside this glossary view, which allows us to navigate around and say click on supplier, and then see all of the details in natural business language for supplier. I can just select this is just HTML, and I can dump that into a Word document. If you're working with FactEngine and Boston, we can right click on the model, and if we've got Windows Microsoft Word installed, we can generate documentation of the entire corporate model, including diagrams. If we're not seeing value in having a property graph schema view of our enterprise model, or the ability to morph between that and, say, the object role model view back to our entity relationship diagram view, then of course we can just throw the whole thing out, export it to, say, a XML file for Irwin, and go back to business as usual, because the chunk of our investment long term is going to be in this semantic layer and our data vault and databases for our data lake. We're providing a semantic view with relatively low risk that sits over the top of that, which gives you huge chunks of value from different perspectives. So from a business analyst perspective, or a knowledge engineer working in the information technology department working on the data warehouse, for CTOs and CIOs who want to be able to report to the CEO and the Chief Executive Officer and explain how this level of value has rarely been seen in the industry before, and where it's packaged together in one bundle. So if we bear that in mind, let's have a look at other ways we can use FactEngine Knowledge Language to help create our enterprise model in the first place. Let's have a look at the knowledge extraction tools inside Boston. If I'm a business analyst, and let's say I'm working on a data warehousing project, and I log into Boston, and I do that over an intranet, an extranet, or the internet using the user-based permissions in Boston, and I look through the business rules for customer, and let's say I agree with all that. I'm a pretty savvy business analyst, so I look at the entity relationship diagram view, and I look through everything, and I notice that I'm not storing anything in my data warehouse about the industry awards that are used for payment for our employees. And I'm thinking, well, you know, if we want to do any reporting on the rates, or keep historical records of the rates that we paid employees over time, and let's say we have to do some ESG reporting, etc., that needs various pieces of data that are specified in various pieces of legislation, etc. We can go to our model, and we're going to pick on the business view now, so our Northwind business view of our data vault, and because that's a good place to start. Let's go to the knowledge extraction tools in Boston, and I've got a whole video on using the knowledge extraction tools in Boston, so I'll touch on this briefly and point you to where you can watch a whole video on the knowledge extraction tools in the link below this video on YouTube. Now I'm going to open a document, so I'm going to select a PDF document, and it's a PDF document on retail industry awards. So let's open that document, and it's dumped the text of that document into the document text tab in our knowledge extractor. Boston has various tools to be able to get keywords and relations out of documents, so model elements ostensibly for our conceptual model, our enterprise model. We can briefly just get single word ones by doing step 1, step 2 and using either one of these. Let's just pick on the first one. So it's keyword extraction. Now that should come back fairly quickly with this document because it isn't a very large document, and return a list of words that might point to either entities or value types which form the columns or properties or attributes of entities in the entity relationship diagram view or the property graph schema view. We can see employee is highlighted blue already because employee is already in the database, and we have a rank, an entry difference, and the frequency that it's been used in this this document. And we can go through those keywords and make decisions on those. So for instance, casual is something that's not in our data warehouse, and it's used in various places throughout the industry award. And we know that an employee can have say an employment type of say full-time, part-time or casual. If we go to our ERD view, I can't see that against employee. Now we might have a date ranged view which says that an employee had employment status on a particular date or a date range, but for simplicity's sake let's put employee employment type directly against employee. So I'm in my knowledge extractor. I've got access to the virtual analyst, so I can say that an employee has one employment type, and let's say that it's written as text fixed length and we allow for 20 characters. So the document itself has prompted me to create something that isn't even in the document, but I'm going to add to the model. So I'll hit go on that, and it says, would you want create a fact type employee has employment type? I'm going to say yes, and that'll be in my model now. But then I can say employment type includes full-time, part-time and casual. Now if I hit go on that, that will have been created automatically for me, such that if I go back to the glossary and refresh the glossary, I should see employment type, and we can see that possible values for employment time are full-time, part-time and casual. So just by using the knowledge extraction tool, it's prompted me to update the model. Now I can't see anything much else in this particular view that I would use, but we might want to store leave as a table in our database and record employee leave that's been taken. So we can add to the model and say add that as an entity type, and now leave will be in our model as an entity type, and it's asking me to provide a unique key for it, which we can do at a later stage. So that's one way of extracting information from the document. Now I can use Core NLP, which is a natural language processing tool, to do further analysis of the document to get multi-part keywords, and even provide suggested fact type readings or business rules of relations or associations between various object types within the enterprise model. So that's finished fairly quickly, and I can go through there and see that it's picked up award. Now we want to store information about awards, so we'll just say add that as an entity type, and that will have been automatically added to our enterprise model. We can store information about, we've got industry awards or award, we've added that already. Now these are roles, so perhaps being in customer service or retail or being a clerk, for instance. So just by looking at that, I can say employee has one employment role, and I'm going to make that a value type, and I'm going to say it's text fixed length again, and I'll give that around 20 characters. So as a business analyst, I've identified that I need an employment role. Now, bearing in mind that our analyst may say, well look, this needs to be date ranged because people change their roles, etc. But just for simplicity at this point, we're going to add an employment role directly onto employee. And Brianna says, would you like me to create that fact type? I'm going to say yes. And in our Northwind data warehouse and whatever database we have for our managing our enterprise, we might say that employment role, which we know is a value type, includes sales assistant and say accountant, line manager, etc. Now we'll just add those for now and hit OK, such that when I go back to the glossary, refresh the glossary, we'll have employment role in there. And if I'm another business analyst looking at our data warehouse or our enterprise model, I can see that what's an employment role? Well, it's a sales assistant or accountant or a line manager. It's the role played by the employee. But we might also create a description where we say, if I open the descriptions dialog box and click on employment role again, oops, here we go, I can say employment role is a role played by an employee, just in natural language, e.g. sales assistant, and just step out of that to confirm it. And there's our informal short description for an employment role. So if I'm another business analyst who comes along, I can say, okay, well, an employment role is a role played by an employee, say sales assistant. And as I develop the model, I can then use the virtual analyst or directly inside the entity relationship diagram as if I was using a traditional tool, or as an object role model using the toolboxes, etc., to create the model, map a relationship between say an employment role and an industry award. So there's those tools, plus if you have access to a secure large language model, we can use a large language model to extract keywords and relationships as well. Now when I did my core NLP, in the results tab I have various suggested relations. So amount is a bonus, that's fine, but let's say that I wanted to say that a bonus has an amount. I can highlight that, dump it down to the virtual analyst, put the word in there 1, and then written as, and money, and I should be able to just hit go on that, and it says, do you want me to create an entity type for bonus? I'm going to say no. Value type, I'm going to say no and redo that. So let me find bonus has one amount. I'm going to say that a bonus is an entity type, and I'm going to say that amount isn't, but it is a value type, so it'll be a column or an attribute. And no, we don't want to add an entity type for money. And if I just redo that and say bonus has one amount and create the fact type, then that's in my my model. So bonus has one amount. So I've used a document to be able to update the enterprise model. Now what I can also do is tie the document back to the model. So if I map the model elements in the model to the document and hit go on that, that might have finished already. That if I go back to the glossary, refresh the glossary, say click on bonus and look at its data lineage or its metadata lineage, I can see that it was actually specified, or we got the idea for that particular model element from the Retail Industry Award. Well, that's helpful. And in the metadata we've got the page number, the line number, and I don't think they're actually right, but the location of the document and the document is right, such that I can open the document and actually view the industry award inside Boston. Now I can use looking at documents another way as well, is that if I have a copy of the document open, and we can maximize that to have a look at it, if I'm looking at any one particular page, say on Shop Assistant, I can get the page text for that, go back to my knowledge extraction tool, go to the document text, delete what's there, and now that I've got my information directly from my document, once again I can run, say, Core NLP over that particular excuse me, part of the document, and extract even more knowledge again to be able to put in my enterprise model. So that's going to take just a couple of seconds to come back, and we can see that it's updating the words and given me more information in the results view for us to be able to further update our corporate model and flesh it out, so that we have the different views for the different customers who would be using Boston and FactEngine to look over the enterprise model, and to be able to use it as a semantic view over the top of our semantic layer or our data warehouse. So we've used FactEngine Knowledge Language extensively throughout the tool, and to recap, FactEngine Knowledge Language is a subset of the grammar that's used for verbalizations in object role modeling, which forms a core component of Boston and FactEngine, providing the semantic information to be able to have semantic information within a property graph, so our predicates on our edge types, so order was taken by employee, So too with our entity relationship diagram view. The type of entity relationship diagram view used inside Boston, we have predicates on our foreign key relationships where an order was taken by an employee, and so too within our glossary, where we would find within here order was taken by, at most one employee, and using FactEngine Knowledge Language, etc., that could be changed to one employee. So thank you very much for watching. That's creating a enterprise corporate conceptual model using Boston and using tools such as FactEngine over the top of the object role modeling meter layer within Boston, acting as a semantic view for what can be seen as a enterprise knowledge graph, as a relational knowledge graph, or under the graph relational paradigm. Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.